Lesson 4, identifying functions and using function notation. So before we go into functions, we're going to talk about what a relation is. So a relation is a little more general term. It's a pairing of two values. We call them an input and output. So it's a pairing of input and output variables. The domain is the set of all your input value. The range is the set of all output values. The input values, or the domain, we call that the independent variable. The output is the dependent variable. So it depends on what you put in. Now, a function is a specific type of relation. So in other words, all functions are relations, but not all relations are functions. So a function is a relation that matches each input with a unique output value. So it is a relation that matches each input value with a unique, that means there's no other one, there's only one unique output value. So if we had our input, and we'll just draw our set inside of a little circle and our output inside of another circle. So if we input a 2 and a -5, and with the 2 we get out a 4. So we input a 2 and we get a 4. So far so good. If we input a -5, sometimes we get a 7, sometimes we get an 8. This would not be a function. So our domain is 2 and -5. And our range is 4, 7, and 8. And because the 5 can be either 7 or 8, it doesn't have a unique output value, so this is not a function. If we had an XY chart, let's say we have for X, we have 4, 4, -3, 0. We have 5, 7, 9, 12. Now in our input, we have 4 listed twice, but there's two different output values, or two different ones that match with the 4. So this is not a function. The domain in this case would be the 4, -3, and 0. And the range would be 5, 7, 9, and 12. Notice we list the 4 only once. If you want to see an example of a function, let's use our input and output with our circles here. If input is -5, -2, 0, and our output is 4, 2, 1, -5 goes to 4, -2 goes to 2, 0 goes to 1. This is a function. And the domain is -5, -2, 0. The range is your output values of 4, 2, and 1. If you're looking at just a picture of a graph, you can use what's called the vertical line test. You just imagine a vertical line, going down anywhere on the graph. So if we had a little sine graph here, and we want to know, is this a function? If you imagine putting a vertical line down anywhere on this graph, there is, so say this were my x value, there's only one value that goes with it, one y value. If this is my x, there's only one y. If this is my x, there's only one y. So this is a function. because it passes a vertical line test. Now if I had a picture of, let's say, a circle. So if we had a graph, and on our graph is a circle. So imagine drawing a vertical line right through our x value. Here's our x. There are 2 y values. So this circle is not a function. This is not going to work. What about this picture if we had a square root? A square root, y equals square root of x. So here's that graph, looks like this. Would you say that is a function? Yes, you would, because every x value, there's going to be 1 y. So every x, you can only take the square root of that, 1x. So this is a function. When we use function notation, so sometimes we want to write our functions using, we use parentheses and letters. So for example, if I want to say f of x equals x plus 2, this doesn't mean multiply. Remember how before we used to say of always or usually means multiply. This does not mean multiply. This just means a function in terms of x. And that it just means that whatever value x is, if we add 2, then that's what f of x is. It's just another name for y. Or if we had g of m equals m minus 3. This is a function in terms of m. So whatever number we want to plug in for m, if we subtract 3, that will give us our range value or what g of m is. That's called function notation. That's the end of lesson 4.